Okay, in the last two sessions, we have seen the basics and we discussed about what is agent, what is a agent, PDA, perceive, decide, act, decide in other words like reasoning, and this PDA is in loop. And we also have seen the context, tools, and memory. We discussed about them also. Now I am going to show you practically how we are going to create one AI agent. If you look at this files, tool schema.py, Python file, this tools is an array. You can see there are two tools here. This is one tool and there is one more tool here, the below one, right? And if you look at this one, basically it is a kind of metadata, right? So the metadata for this tool is, what we are trying to say is, this is type is function, name of this tool is get weather, and the description is like what does this tool do, returns the current weather for a city. And the parameters for this tool is that if you look at the properties, city is a string and there is a country also, country is string. And I have created a required parameters for this function is city and country. Okay, city and country is the required parameters for this get weather. These are basically the inputs. Okay, that's how we defined. This is the tool metadata for this. There is also one more tool. In this demo, we are not going to use it. A simple another tool where the function name is the calculate. Basically, it is for the calculator. And the parameters is the expression and all, like 25 into 18 plus 42 kind of thing like. Okay, this is the tool schema. Now, I will show you, there is one more Python file. Tool registry, if you look at this tool registry, okay. This is where I particularly import the exact function that are kind of like API that I am going to use. I mean, this whole demo is about the weather agent, right? So user gives a context, like, he puts a question saying that, okay, give me the weather of Mumbai or Hyderabad, something like that. And we should be able to get the weather. Okay. And if you look at it, I am basically, importing from integration. There is an integrations folder here. Okay. In this integrations, if you look at this weather, so there is a file I created, open_meteo.py. From here, I am importing the class OpenMeteoClient. Okay, calculator, you forget it. Okay, and then I am initializing, like I am instantiating a object here. This is the class, and I am instantiating an object of OpenMeteo class. And in the tool registry, I know there are two tools are there, get weather. Okay, so from the weather, current weather is the tool. I'm trying to say this is the key. So when we are trying to execute, you see this one, this is very important one. This is what, if you remember when I mentioned, when we give the context to the LLM and the tools information that we are going to give is the tool schema, which I mentioned, which I explained to you earlier, right? The two JSONs and all, tool array. In that, in the execute tool is called, so basically the tool name and it will take arguments and all, and it will get from the tool registry here. Okay. In the tool registry, it will get it. It's like a key value pair, right? In our case, it's the get weather is the tool name, and this is what function that will be executed. Okay. So it will be executed here, passing these arguments. Okay. Now you have seen how the function are being executed, right? Okay. Now then, you want me to show this OpenMeteoPy also? Okay, this is what it is. You can see. This is the class, OpenMeteo class and all. Okay, basically what we are trying to is that we are taking the geo URL, weather URL is there, and then current weather. Okay, this is the function we are exposing as a tool. And it has taken city and country as input. That's what we described in the tool schema also, right? And this find city, if you look at this one, find city, this is the another function given the city and the country. So it will make a call. It's a simple URL HTTPS or HTTP REST API call, right? So it will make a call and okay, GURL, this is the URL, right? For this particular URL, it will make a call and it will give the location like coordinates, right? latitude, longitude. Okay. So this is the information it will give, and that particular information LLM will take and try to give the weather information for us based on whatever the question that we asked. Okay. Now go back. So that's all. These are the basic things. This is about the tool. Now let me show you main.py, right? Okay. What I'm doing this main.py. So in the main.py, this is where when I execute this, Python main.py, basically it will come to here, and then it loads the environment file. Okay. I have created .env, right? In the .env file, I mentioned OpenAPI key, OpenAI API key equal to sk something OpenAPI will give to you. That particular key you need to mention here because that's where it will hit the LLM. And from agent no memory import run agent. Okay, look at this one. This is my agent. Okay, and run agent I am importing it. I am going to use this run agent inside this main. I am going to create a session ID. Whenever we run this file, basically we are going to create a session ID. And while true, yeah, this is what I have shown, right? Like open AI underscore API underscore key. This is something that you need to mention in your .env file. And it will read it here from load.env. Okay. And while true, in a loop, this particular agent will ask questions to us in a loop. And when we write exit or quit, it will quit. Okay. What all it does is that basically it will call this run agent and it will pass the client. Client is what? OpenAI client. This one. Okay. OpenAI client. And the question is what we have asked to the prompt, right? Basically input is the prompt. It will say you prompt and we'll write a question here. We'll put a question. So this OpenAI client object and question and session ID, whatever this particular session it has created, it will pass. Okay. Now we will see the run agent. What exactly this run agent is doing. Okay, this is interesting. You see this flow? User asks a question. It goes to the LLM tools metadata because we are going to give this tools metadata whatever we created in the tool schema, right? I have shown tool schema. This is the tool schema, no? This information is what we will be giving to the LLM. That metadata LLM will see based on the question that we ask, it will identify the respective tool. Okay, and it imports tools, prompts. I will explain to you what exactly these prompts will do. Okay, this agent is no memory agent. That means it will not retain any memory. Every time we ask a question, it will take it. That's it. And run agent, if you see, okay, this is where we are making a call to OpenAI. We are saying that use the model GPT-5, which is costly. I think I should use cheaper model. I will change it later. And instructions, I will show you these instructions later. Input equal to user question, the question that user typed it, and then tools is the tool schema. Okay, these are the tools that are sent to the LLM. So LLM can choose the which tool to be used for this particular question for the goal to be fulfilled. Okay, step equal to 1, max step is 10. So what happens if I put while true? It is possible that this agent may be in a infinite loop. So we should avoid it at all cost in the production systems. That's where I have created maximum 10 steps. That means to arrive at a goal, I will explain to you. If we ask, okay, what is the weather in Hyderabad, probably a single step is enough. It will basically will give the Hyderabad, information, city information, Hyderabad and India, get the latitude, longitudes and all from the open the Meteo, and then it will display to us. But what if I ask a question, hey, compare the Hyderabad and the Mumbai weather? One step is not enough, no? It has to bring weather from Hyderabad, it has to bring weather from Mumbai. That means 2 calls it has to make to open Meteo. For that, it has to make, even the LLM has to decide that, there are 2 steps are involved in this one. You got it, no? This is the multi-step agent. So in a production system, generally, it's always the multi-step. For any goal to be achieved under, it's a rarely single step. It involves a lot of steps. At the same time, we can't keep in a while loop. That's the reason I mentioned, do it 10, max steps are 10 only. Okay. Otherwise it will LLM will eat up the money, no, it will be costly. Okay, now I'm printing the each step. Okay, you can see this one, and LLM requested tool, basically it will give us the output to us. Okay, this is where we make a call, we got the response. From the response we parse it, and then we understood it's a function call, it's a item type is a function call. If it's a function call, then what we do, we execute the tool. We take the tool name from this function call, name is the tool name and arguments is the arguments, and from the tool name we pass this execute tool. This execute tool, if you see it, from the tool registry execute tool, that's what I showed you, know. And then we pass this tool name and arguments. Okay, so tool name is the execute tool, right? Weather agent in this case. Okay, and the tool result, we are printing the result, and the tool outputs we are appending it. Okay, and response, again we are making a call. This is tool outputs. That means if you understand PDA, context with perceive, and then decide, like checking which tool is useful, I mean which tool is required, because the LLM needs additional information for that, and then act. So when it acted upon it, that is the first time it made a call, no, to the LLM and all. Here it acted here. After acting, whatever the information or whatever the result that it got, that result will become the again perceive context for the next call. That's what it's happening here. Okay, so it's making one more call here, and input equal to tool outputs. That means the first call's output will become the input here. That will become the context for the next subsequent round. Okay, that's all it is. No memory, nothing is involved. It's simple step. So this VENV, if you look at it, generally it's always better to create the virtual environment. You can always do this Python 3, okay, -m venv.venv, right? If you do this, it will create the virtual environment. Okay, and there is a requirements.txt. Where is that requirement? Yeah, if you look at this requirement.txt, you see, so I mentioned whatever the required libraries for this particular program. OpenAI, I have given the version also. Python, this is to load the environment details from the .env. This is required. Okay, request is basically to hit the OpenMeteo REST. Basically, it's a REST client. Okay. Now that's what it is. So I have explained to you the tools. I have explained to the agent. Okay, and now let me execute this, and let us see what will happen. Python 3 main.py. You see the session has been created. Okay. Before that I will do one thing. Yeah, no problem. Okay. Okay, session has been created. Now what is the prompt I will give? What is the weather in Hyderabad, India? You see this one, step 1, LLM requested tool get weather. Okay, so this is the context I have given to the LLM. This is the context I have given. And what LLM has done is that it thought that it perceived this and it understood this information is not enough. This is the question we put. For this question, LLM need additional information. That additional information is, we have given the tool schema, right? From there, it asked us, hey, use this get weather tool, execute this and give me the response. That's where we executed this get weather tool. And the arguments, we printed everything. The arguments to this is city, Hyderabad, country, India. That's what LLM has decided, because based on the question only. When we asked this, what is the weather in Hyderabad, India, LLM itself decided this particular tool require a city and country are the parameters, and city it has taken Hyderabad, and India it has taken as the country, because LLM knows it. No. Now the location also it has given, that geo URL, right? That geo URL has given the location, Hyderabad, latitude, longitude, and all, and elevation, all these things. Okay. So this context it has given, and also it has given something else, tool result, city Hyderabad, country. Now additional details as temperature 23.3, wind speed 17.7, weather code. Okay, it's good. In step 2 it has answered, agent answer is, here is the current weather in Hyderabad, India, temperature. I mean, it has taken this response and given the response to us in properly, temperature separately. You see in this one it has given the JSON format, right? Tool result. But here it has given in a readable format, like temperature, conditions, wind separately. And it also asked us, you might want a light rain jacket or umbrella. Okay, it tried to give us some suggestion. Now I would like to ask a question, right? um Explain how different, or I would say compare whether Hyderabad versus Mumbai, India will give. So I am asking the LLM AI agent, I mean the weather agent. If you look at the design, actually that particular agent do not know that it is going to interact with weather agent. I will show you why. That is a generic agent. Based on the question only, LLM has picked the get weather tool. Now LLM requested tool, step 1 is get weather for what? Hyderabad. So the first step is it has got the, it decided that in a multi-step. Okay, you look at this one, the step 1 it has decided to make a call to this one to get the weather details about the city Hyderabad. Okay, and here also LLM requested tool, again there is a one more thing, no, one more. This time it requested for Mumbai. Okay, in the step 2 it has combined both and did the comparison. Agent answer is, here's a quick comparison of Hyderabad versus Mumbai weather. Current snapshot, Hyderabad this one, Mumbai is this one. Hyderabad 23.3 degrees Celsius, Mumbai 25.9 degrees Celsius. It's a light drizzle Hyderabad, it's a moderate rain in Mumbai, and it's a 17.7 in Hyderabad, the wind, and it's a 17.4 in Mumbai. So it tried to compare. And the typical differences through the year. So it tried to give us the seasonal differences also, like a climate type, temperatures, humidity, heat, feel. You see this one, this is what the multi-step. Okay, it even asked us, like, do you want to have a 7-day forecast or best time to visit, this comparison. So basically what did it do? LLM understood that to do the comparison it requires a get weather tool. So it asked us to make call to with the city Hyderabad once, and again it asked us to make a call with city Mumbai. So 2 times we made a call and we got the information and given to the LLM again. And the LLM at the second round, what happened? It has taken the output as input and then it did the comparison. Okay, so LLM is going in a multi-step, right? So it's not a fixed thing. It can go even up to 9 step, 10 steps also. I don't know. Like maybe if we give a complex query, okay, it may go even few more additional steps. Okay, now I want to show you one thing here. My name is Arnold. Let's say what it will do. The agent answer is, nice to meet you Arnold, how can I help you today? So it did not find the tool, but generally it has given me it understood. So this agent, when the agent has sent this information prompt as my name is Arnold to LLM understood it does not need any additional information. That is the reason it did not check for the tools. Instead it straight away gave, hi, nice to meet you Arnold, how can I help you today? Understood? And then now I will ask a question like, what's my name? You see this one? Earlier, when I say my name is Arnal, it says nice to meet you. Now, when I say what's my name, it says I don't know your name. I don't have a tool that can look it up. What would you like me to call you? You see, it does not have a memory. This is exactly what I'm talking. This is the memoryless agent. Whatever the context we give, until that goal is passed, it will work in a multiple steps and all, complete the goal and it will forget everything about it. Again, if we ask again, it will start from the fresh. It does not know what we asked him. So this is what memoryless agent. Okay. In most of the modern AI agents, memory is important. Okay. Because imagine that we are working with many systems and all. The agent sometimes has to remember the past, decisions. For example, when the agent we are going to write or the use is going to find a fraudulent transactions, then definitely it has to remember the past transactions, no? Whether how the past transactions are, the patterns, how many transactions are fraudulent, what kind of transactions they were fraudulent, etc., and all those things, right? Based on that, those things will become the context for the current query, and it will give the proper response. Okay, now I am going to make a small change here. The change I am going to do main.py, right? Okay, I will clear it. If you see this one, I am changing run agent, the agent with memory. Earlier it is agent no memory, that's one agent without memory. This is agent with memory. Basically, it is the agent which can remember. Okay, this is the file. I will explain you this file, but first I will run and show you. Okay. Let me run. Okay, this time my name is Frankston, let's say. Okay, it says, nice to meet you, Frankston. How can I help you today? Now we'll ask it, what's my name? You see, the answer is, your name is Frankson. Earlier, when I use agent no memory, it actually says I don't know. But when I use this agent with memory, this because I added the memory for this, it's able to say your name is Frankson. You just gave me that information. That means it has taken the information from my old command, the output, input, and everything. It remembered it. And when I try to ask a similar question, it got the information from my earlier questions and all, and it replied to me saying your name is Frankson. Okay, I will show you how that is happening. What is the changes that we have done for the agent to become the memory, If you look at it here, tool register is same, there is no change. Tool schema also is same, no change. Memory is something that I created newly. Okay, if you look at memory here, you see, this is the class. Okay, in the memory class, if you see this, there is like it has the variable, okay, class variable, that is the memory store. Okay, what is the memory store here? You see, and memory store is basically accessing this memory file. Let me open this. Where is this memory file? Memory.json. You see this one? You see, the last chart, what I asked is, user, what's my name? Okay, assistant's answer is, your name is Frankson. You got it? This is how it is storing in a memory. Today I'm using a simple JSON to store the memory. In the production systems, this can be another tool which can access the database. This can be a Redis enterprise cache. Okay, it can be anything. So for the demonstration purpose, I am using a simple file like memory.json. So if you look at it, a role user is something that as a user I am asking the question. As a user, as a role, the content, the question that I ask is what's my name. That became the context, that is the perceived to the LLM. Now, agent, right? Now the role. That means this is the answer from the agent through LLM. So it became there role as the assistant, because the agent is the assistant for us, right? And the content is your name is Frankson, the answer, second time answer, right? So everything it has stored here. If you look at here, user, session ID, in the last session ID, the role is user, content is my name Frankston. This is what I have given. No? So basically when I ask what's my name, it has gone through this context. It has loaded this, all this information based on this session ID. Okay. When it loads this session ID, it will get all this information. From this, all this information, it will have picked my name here because I have already given it. No, my name is Frankson. That's what it returned to me. Your name is Frankson. Okay. So these are the additional clauses, like that handles this memory.json and all. So it basically it writes into it, load it, save it and all. When we give the data, and all, it can append, it can write and all these things. Memory.py, okay. So it has taken the session ID, and when we make a call to load, it takes the session ID and it loads based on the session ID. If you want to append it, we have to give the particular session ID. For that particular session ID, we have to give the role and the content. It will append to it. Okay. So, and again saving. Okay. Now, agent with memory, right? Where exactly we are using this? If you look at this in the run agent, the first line itself, this one, I bring this history, memory.load, given the session ID, we are bringing that whole chart related to that session ID as a history. Okay. And then I'm adding it to that particular chart. I'm adding the new content. That's whatever I have asked newly. That's the content user question. I'm adding it, right? When we made the first LLM call, okay, again model we are giving. It is the same thing. Nothing. But what different here is that earlier, if you look at it, agent no memory, you see this one. The input we have given is the fresh question. Whatever the question that we asked, that is the fresh question, no? That question only is going to the input. But here, as in this case, I am giving entire history here. The input I am going to give is the entire history. That means including this history plus the new question. So I have given everything to this LLM. That is the reason LLM is able to understand. Now, so if you look at this, the same thing, max step is 10 here also. Okay. Here also max step is 10. And steps also, here also steps are same. If you look at the same thing, same function call, if it is a function calls, then it gets the tool name by name and arguments by arguments. Then we'll print it requesting the tool name, arguments are this one. And then it makes an execute call with the tool name and arguments. Okay, execute call is there in the tool registry, right? Okay. And then this tool outputs, whatever the result we get it, right? And then we dumps it, no? Okay. Output is the JSON dumped result and all. And then response is again, the whatever the tool results that we got, we'll give it back to the LLM, because LLM maybe need to do the reasoning, or it wants to present the answer in a presentable way. Okay. And the response we'll get, final response is this one, right? Final response equal to this one, the text and all. And this is where we are appending. You see this one? We are appending the user question and we are appending the LLM answer also. Okay, you see this one? And then we are returning the final answer. After returning the final answer, what is happening? We are printing it here. Agent answer is this one. You got it? Now, let us do the similar thing, right? Okay, this time what I will do? What is 23 to 7? You see this one? There is one more calculator tool which I have shown you in the tool schema. Okay. Calculator, right? It has taken this time as the calculator. You got it? So expression tool result is 161. Step 2 is it has given us in a. Okay, now I am going to give, let's say, one more question I want to give. Okay, what is the question I asked latest, let us say, what does it show? You see, what is the question I asked latest? It says because this question itself is the latest, that's why it is giving. Suppose if the same thing, if I ask a human can understand, I cannot give this as an answer. Okay, that's the reason it has safe side. It has given it was what is 23 multiplied by 7. No, yeah, this is exactly. So it's able to identify. Not bad. So this is the memory. We have seen the P perceive, that is the question that I am giving, or the history memory along with memory that I am giving. The decide is the reasoning, because that is the tools that I am giving to reason it out. If the LLM requires additional information, it will give us the tool name and say that execute this tool and give me the response back. And application, the so-called application here is that agent with memory or agent no memory. Basically, they were agents only, right? So LLMs won't execute. So these are agents as part of the application. Okay, they will execute the tools and the response is given back to the LLM, right? And act is based on that information. Okay, LLM will say, okay, application will LLM will say execute this particular tool, and agent, these things, or application will execute that tool, and again the answer is written back to the LLM, right, for the final reasoning and all. Okay, let us give one final query and complete it. This time, how different the weather conditions are from India versus, I don't know how it can behave, because our tool, if you look at it, it requires city and country. I'm not giving any city here, or probably I will give city. Conditions are from Mumbai, India versus, which one will give? Probably any city in European country, or should we say specifically some country, or Australia. So the question I asked is how different the weather conditions are from Mumbai, India versus any city in Australia. Let us see how it will behave. It's taking time. So this prompt, this question has been given to the LLM and LLM is taking time. Basically, okay. Step one is, which Australian city would you like to compare with Mumbai? You see this one? Because the reason is it knows there is a tool to execute, that is a get weather, because the context here is that weather conditions. But at the same time, it knows the required mandatory parameters are city and country. It got the country, but the city name is not there in the Australia, right? That is the reason it asked us back. It asked us back, give me the additional information. Which city? Probably I will say Sydney or Melbourne. I would say Melbourne. Okay. Step 1, LLM requested tool get weather. The first request LLM make asked us to is to get the to make the tool call of get weather with city Mumbai, country India. The second time it asked us to execute the same tool with city Melbourne, country Australia. It got some details. The next step, it try to whatever we asked, right? Okay, now it understood, it got the information. The next step is that it just needs to compare. Okay, suppose if our question involves too much of complexity, and then probably it may even go for further steps. Okay, okay, probably I will ask it, have to ask a complex question that involves 10 steps. Calling I don't know how it behaves. Let us see. Get weather tool. What that question would be. Probably I did not ask the proper question. Let us see. I'm just asking is give me the complex question so that you take 10 steps to do. Let's see if it understands. It gave me. What are the current weather conditions, temperature, humidity, wind description in each of these 10 cities? Mumbai. Acha. So basically, we have to provide 10 cities. Let us see. Australia, and based on those readings, which city is the hottest, which is the coldest, and what is average temperature across. This is kind of like a bit analytic one. If you see this one, step one, it is making multiple calls. Okay. You see, so many calls. LLM requested tool. Okay. Meanwhile, we'll see this one. This is run agent. First call. First call, it made a call, and then the first step, step one, function calls. Then it has to reason out, right? Okay. In the step 2, I'll retrieve current weather for each of these 10 cities, then compute the hottest, coldest, finally identify the Australian. It did not, it retrieved it, but it did not summarize it. You see, it did not do properly. The question we asked is different. We asked is find out the hottest, coldest cities and all, but it merely got the information, but it did not summarize it. Okay. So this is a kind of like a hallucination and all. This is the problem with the LLMs. You see this one. When we are working with LLMs, we need to be very careful. Our test shoots also, we have to create test shoots in such a way that whenever we do the modifications, small architectural changes and all, those test shoots has to give the definitive answers. Okay, because there's always a possibility LLMs will go hallucinated and all. Okay, thank you very much. This is the first AI agent hands-on explained to you.